So, then there's encrypted tokens, and this, like I say, is where it gets pretty esoteric, and I'm a little skeptical. All right, so the idea is you start with a meaningful token with something in it like a username, and then you encrypt it. And you use symmetric encryption with a secret key that's only on the server and never given to the client. So that sounds pretty good. And it could be good, but there's a lot of things you can do that will go wrong with encryption. Encryption is just a whole lot harder than people think it is. Most people, when you code encryption, you code sloppy encryption that doesn't really hide all the secrets you need to hide. So the simplest mistake is ECB. This is one many people have made over and over and over. Microsoft made this mistake twice. In Microsoft Word before 2008, if you encrypt a file with a password, it doesn't have any randomness using ECB mode. So if you encrypt another file with the same password and just exclusive OR them, whole regions of text become plain text. This is a general point. Electronic code book means there's blocks of input that turn into blocks of ciphertext, and if you have another block of input that's identical, you get the same answer. It just does one process, there's no randomness. So this, I'm thinking I might put this project into class. I used to do this in 120. This is the famous problem. If you encrypt an image and the image has blocks of solid color, then you just get blocks of solid color because it's encrypting 8 bytes at a time. And so here's 8 bytes of all yellow, and that turns into whatever this is, green or something. And the next byte is the same, and it is the same. So, well, a normal human being would say, this is not encryption. I can still see the pattern. You haven't really ruined it. Now, what you have done is blur the edges a little, but you haven't really concealed the information very well. That's the problem with this kind of encryption. So here's an example of it. So if you start with this junk, rand equals this, app equals that, user ID here, username there, time there. If you encrypt it 8 bytes at a time, you just get garbage, apparently random bytes with no apparent structure. The problem is you have 8-byte blocks, right? So this means I do not know how to convert plain text to ciphertext and back, but I do know it's doing it in 8-byte blocks. So notice I've got like 000 here and things there. So I could take a whole row and repeat it or move it as a unit because each row could be in any order. So you can do this. Down someplace I found a row, right? The second row contains 992. So I can just put it here, and now my UID has turned to 992. And other things have turned into garbage, and some things are now repeated, but I don't know what the server's going to do with that. If I'm lucky, they won't notice that they're duplicated, just take the second value. They won't happen to be using the parts I've destroyed, and now I'm going to be using 992. So even though I can't decrypt it, I might be able to get away with this, rearranging it, like pieces like this. And if you want to be even more precise, now you create a new user, and you carefully take the new user's name, the right length, make your username daf1 so it will wrap around here. Now you have a 1. Now you can make user ID equals 1, which is likely to be the administrator. So it's actually pretty clever, and that's what you get for using ECB. I make no attempt to figure out the encryption scheme or the key. I just use the fact that it works in blocks, and usually 8-byte blocks. And you can do things. So cipher block chaining is what's recommended for exactly this reason. And the way cipher block chaining works always sounds like a bad idea to me. You take the plain text, you feed some kind of initialization vector to get it started, you encrypt it, and then you take the output of that and you exclusive OR it with the plain text here before encrypting it. This makes some randomness added to this one. So if I have another block of plain text and it's the same, this is not the same, so I don't get the same result. So the reason this is highly recommended and is the standard for most projects is it has the obvious effect, it turns the apple into that. That's what you expect encryption to do, right? All traces of the input pattern are gone. There is no way to tell what that image is anymore. But the problem is, here, we are controlling the ciphertext. Remember the server had this readable string like username and user ID and stuff, and it encrypted it and it sent us the ciphertext. Now we're sending ciphertext back to the server, which is decrypting. And the way this works, it XORs with the ciphertext. So I can manipulate the ciphertext. So here's the game. I got these meaningful token, and here's this encrypted junk that appears random. So what you do is you make a small change in the input, like just 1 byte or 1 bit. And what that will do is it will have only a small effect on the output because the XOR will only affect that byte. So if you make small changes, they will propagate through. They will not completely destroy it. if you're changing just 1 byte at a time, it will just hit a few bytes as the XOR percolates through. So you'll mess it up pretty badly, but sooner or later it'll hit the right byte that just changes like 1 character in a name, and sooner or later it'll hit a byte that changes 1 byte in the user ID. So it has a similar effect, that it's not like a hash function where changing 1 bit changes the whole hash function to just garbage. Changing 1 byte with cipher block chaining just sort of hits certain strategic spots. So even without knowing the key or the routine, you can still try a reasonable number of guesses and get through. And what Burp does is it has this session. This is what someone was asking about earlier. Here's more or less the steps for it. You go to Burp Intruder, and this is, yes, Intruder. Then you take your request and you highlight the part you want to use. So now it knows. You specify that as the part we're going to play with. And then you tell it to flip the bits. You can flip only certain bits out of each byte. If you check all 8, it will now flip 1, 1, 1, 1. 8 requests per byte. It will just flip 1 bit. And then flip 1 bit of the next byte and walk through all the bytes there. So it really won't take that long. That looked like maybe 30, 40 bytes of text. It'll just take 8 times that many requests to try flipping 1 bit. And like I say, if it's using one of these vulnerable encryption routines, there's a fairly high chance that flipping 1 bit will still result in valid data pointing to another user. And it doesn't take too long. And here's the results. You have request numbers, which bit was flipped, and this is you, and these are unknown users, and here we hit a couple of other people's accounts. So it did successfully change the UID to something else, and so we have succeeded in getting into somebody else's account. It's kind of scatterfire. You don't really know what you're doing, but you have proven it's not random. And one thing he says that's recommended about this thing is just doing this 1 bit per byte won't take long at all, and it will tell you if it's vulnerable. It will look if the results are random or if the results are show any pattern. So that's an option and might be worth playing with. I may make some version of that for a homework. I'm thinking about it. All right, so here's other things that can happen. You may leak out the encrypted text elsewhere. This happened to Facebook about 2 months ago. It turned out that the password reset token was actually used for something else on another page that you could find. Yeah?
Quick question. So if you're doing like a large amount of those requests,
Yeah.
and the server is hosted through Cloudflare,
Yeah.
does Cloudflare actually log that event?
No, I don't think so. Now, if you pay for, Cloudflare has a mod security kind of optional feature if you pay more, and that might detect it. It certainly is something your intrusion detection system should notice. You have many requests with invalid tokens from the same user. So I would think if you had any kind of rate, you could pretty easily write like a snort rule to stop this, but they may not have bothered. That's all. Cloudflare, I don't think will do it automatically though. Anyway, so you may, another thing is you might be able to put up arbitrary text. Like in one of the pages, there was like a bank he was pen testing, and he found there was a place where you could upload a file, and then it would send you a download link to the file, which used the same kind of encryption to create the file name. Like you have to believe when I upload images, I get a file name that's the MD5 hash of the image. But it had something else. There may be some place where you can put in data that gets encrypted. And usually people reuse code. They have some kind of encryptor, they use it for everything. So if you can feed up arbitrary text and get the encryption, well then you can feed up text like UID equals 1 and get the encryption. If they reuse the encryption routine. So this is the kind of thing that keeps going wrong. Even when your math is beautiful, your logic may not have thought that over here I leak something which undoes the benefit of all this good stuff. This tends to happen over and over. So the number one skill of hackers is not so much any mechanical technique, it's having the logical mindset to notice that this feature has an unexpected consequence that could be used over here. That's the whole thing. That's how it all started with the MIT guys building model railroads out of telephone parts. Other people just see the intention of the part, and these guys see what twisted thing could I do with that. That's not what it was intended to do. And that's the mindset you need. So then you can handle your token foolishly. So here's common myths. SSL will prevent all of this. Well, SSL will prevent people from sniffing it off the wire, unless they do pretty exotic things. But there's a bunch of ways to trick you into just handing it over, like cross-site scripting, so that the SSL doesn't save you. Another thing is, even if your platform is using brilliant cryptography, there might be some other way to still seal the token anyway, so all that cryptography doesn't really save you. So there's nothing so simple as just use this one product and everything's fine. That's why if you go to RSA, there's a ton of people selling you our $100,000 firewall will protect your network and all your security problems will be gone, and it's never that easy. So Tokens might be transmitted without encryption. If that happens, you can sniff it from anywhere. Anywhere the packets go through, you don't even have to be in the middle. You just have to be within range of the same wireless access point, or, if you can put any kind of sniffer anywhere on the traffic flow, you get the token. Now, if you steal a password, that would be the most awesome attack, but passwords are typically protected, but you don't really have to steal the password. See, my spell checker doesn't work when I make typos that turn it into a word like this. Anyway, so a two-factor authentication would be good. That might be one reason why the password is not enough. You might perform a login over HTTPS. So even if the password is protected, I can still seal the authenticated session after the user logs in and then hijack their session. And another thing about that is, if I hijack their session and execute extra commands they didn't execute, there won't be any log of someone got in your account. Like my Gmail warns me and my Cloudflare warns me, your account was logged into from an unexpected IP, but there won't be any of that if I hijack their session and do extra things piggybacking on it. I remember when I learned how to do this from getting on the wall sheet, and I went to a teacher's conference, and one of the teachers volunteered in Bowne, actually. I hacked into her Gmail right there, and people freaked out. And she said, I'm changing my password right now. And I said, I didn't need your password, and changing your password will not protect you. I'm stealing the session cookie. You're screwed. And we'll be here later, but I tested a bunch of people. It's really bad. It's much more powerful than the password. Anyway, some people don't always use HTTPS. They have some HTTP content, like Amazon totally does, and then they have to really make sure never to transmit the trusted token through the non-HTTPS channel. And that often happens. There are also people where you connect with HTTP and it gives you a session token and you're not authenticated yet, but it knows who you are, so it can target ads or something. Then you log in and it doesn't give you a new token, it just records the fact that that token is now logged in. So in that case, I can steal your token and wait for you to log in and then come in with that token and you're in. All right, then you can think about the back button. Suppose the main page is HTTP, then the login page is HTTPS, then you log in and all the session token is being sent over HTTPS, but if you go back, you'll eventually get back to the HTTP page and they'll send the token up in the header. So if any part of your site is HTTP, I might be able to trick the user to go into that part and get the thing sent in plain text. SSL strip, we talked about before. If you're in the middle, then your login link goes to an HTTPS page. The attacker in the middle just sends it to you over HTTP instead and connects to the server or HTTPS, so the server doesn't know anything's wrong and you don't know anything's wrong, but they're getting all your data. And this is devastating, especially with mobile devices where there's no way to tell if you're HTTP or HTTPS at all. There's no letters in the URL. The URL bar is often not there. There's no padlock. You really would never know that this is happening to you. All right, and now if you have an HTTPS page with some HTTP content, then some of that might be leaking out these cookies and tokens, and it's always been considered a terrible idea, and browsers are beginning to block it. But they only block the most obvious stuff, like scripts. They still let you load images over HTTP and CSS over HTTP, and that still might be enough to steal the token. So then there's social engineering. I send you some kind of HTTP link and go to some page. All I have to do is find some HTTP request that goes to the right domain. So maybe they do have a server on port 80, or maybe they'll reply to the handshake long enough here for your browser to think it's making some kind of connection. I just need your browser to try to send up a request with the header, and then I get the information. So, yeah.
I wanted to ask you about a practical attack, like loading insecure stuff, like an image.
Yeah.
What's like a practical example of session keeping?
Oh, loading the image is an HTTP request, and it's got all the headers in it. So I think the session key would be in there if the image loads from the same domain. Every request is the same. It's a GET, and it puts in all those headers in each one, unless you mark them secure, which is what we're doing. So here's the game. You walk through everywhere, record every URL, notice every session token, notice when it changes from HTTP to HTTPS, and when it gives you a new token, and then you look for mistakes. This token is important, and yet it was used. So this is what Burp's HTTP history does. So here's the demonstration. I'll give you a few minutes, but it already records the protocol and the URL and the token and everything that went through what cookies are sent as you go ahead. It's very handy. You could also do it with Wireshark, but Burp makes it easy. So this is why you have two flags for your cookies, the secure flag and the HTTP only flag. And so if you put the secure flag on a cookie, then your browser will only send it over HTTPS. So let's take a look at this, because it's not as great as you might think. So let me get Burp here. Okay, so let's reload this page. This is an HTTPS page. So when I first loaded it, it gave me an error and I had to approve a security exception so it'll trust my Burp man-in-the-middle attack so I can see it. So let's clear the history. Okay, and I'll show you a few things here. So this form, you can log in as user and password, and you're trying to log in as admin. So if I log in here, it sends a post, and they're good. Okay, so I get in, now I'm user. There's my username. So I sent a post, and the post, wait, I went somewhere funny, proxy. Okay, here's the post. The post went up, and I didn't have any cookie that mattered. All I have is a Cloudflare generated cookie, which is this big random thing, and that's just what they told you about. There are these weird things generated by proxies that I'm not using it in my app. That's something Cloudflare creates for whatever reason, I don't know. It's just a useless appendix. So there's no meaningful cookie. It said I sent up a username and a password. Once I got up there, it went to this page, which set the cookie. Oh, the response to that page set a cookie. So it set my username equals user, and it gave me an expiration date. So now I have a cookie in my browser that says username equals user. When I send it to the next page, then it forwarded me to this page which will say welcome. So the first page is a PHP script just to set the cookie. The next page is the welcome page. So when I go to the welcome page, I send up in the request my username, cookie username equals user. And it takes that data to give me the response that says welcome user. That's how it worked. It bounced this data off me. So that's the game. That's a simple case. Now, this cookie is a normal cookie, so there are a variety of attacks. I added a alert here that just says alert document cookie when you click on this, and I can pop up the contents of that cookie. So that means if there's a cross-site scripting error anywhere on the page, someone can steal my cookie. Okay, so to prevent that, you go down here. This one is set HTTP only and secure. So let's try the same stuff on this page. I log in again, and I'm on HTTPS right now, so I'm going to get welcome user. Now the reason it worked is because I sent a post up like before, and my request sent up the username and password. And actually this one already has the username cookie filled in, so it's kind of rude. How do I get rid of all my cookies? I guess I have to go here, settings, one of these things.
There's a very cool Chrome extension.
Yeah, edit this cookie or something. Yeah, but this is Firefox. I'm going to do it in here. I found one of these things will let me do it. Privacy. Remove individual cookies. There we go. I can put in Sam's class. .info. There are none? Oh, I spelled it wrong. Why, thank you. Good. That'll do it. There we are. Now let's just remove them all. Okay. So now I got no Sam's class cookies. Okay. And now I go back here and refresh that page. And let's get rid of all this old stuff. Yikes. Okay. Get rid of the old stuff. And now hopefully I'll see the right thing here when I log in. Okay. Welcome user. All right. So now my request now does not have any cookie that matters. All it has is that Cloudflare cookie. So I send that up, the server replies, and it sets username equals user, expires, and it also sets secure HTTP only. Those are the big steps. So now notice this request was HTTPS from my server, but even if my page is not secure, it will still let me do it from the server. This secure flag does not prevent your server from leaking the secrets. It only prevents the client from leaking the secrets, which is kind of rude and important to know. So now, when I go to the next page, my request does send up the cookie. And therefore, you see the welcome user. Now, if I make an insecure version of this page, which is just a matter of going to attack direct, that's what I changed it to. All right. And this is token.htm. I'll just go back to the original page. All right, and you lie. But not HTML, thank you, good. I'm glad you people are paying attention. Dot, good. All right, so this is the HTTP page. So let's get rid of the old stuff and see what happens now. All right, so now if I log in here, I get to the welcome page, but it doesn't know who I am. It has an undefined index. And that's because I sent the request here. The request had no cookie, and it sent up username and password. The response set the cookie to say username equals user, but secure. And so it was sent in plain text from the server down to me because this won't protect me, but my browser marked it secure. So when I sent the next request, my browser refused to send the cookie up. This request does not have the cookie in it, just has the Cloudflare cookie, so it didn't know who I am. So anyway, that's what you get from secure cookies. Now the other thing you get from HTTP only cookies is it is only visible to HTTP, it is not visible to JavaScript. So if you go back to this HTTP page and you click this thing, there's nothing in it. And this is where, if I alert 1, I see the 1. And if I go for this cookie, it's there, although I didn't set that cookie by logging in yet. If I log in here, it sets that cookie, and now if I pop it up, it shows up. But this one won't because it's HTTP only, so JavaScript can't see it. So that's why these are the two old-fashioned solutions, secure and HTTP only. Anyway, that's what I wanted to show you there. And here's the PHP set cookie function that lets you turn these things on with true at the end. And here's the thing that warns you that even when you set this to true, it will not prevent your server from sending it insecurely. That is your duty to think of that. It will just prevent the client from sending it insecurely. And so that's how you set a secure cookie, and when you transmit it, it won't be sent. So, it won't be sent over the insecure connection.
How does that work from Ajax requests?
I don't know. It's an interesting question, and you'd have to look into it. It's a good point. A very important issue, too, of course, in the modern day. Maybe we'll get that later in the book. Maybe we won't. Maybe you have to figure it out. Yeah. Anyway, so, all right, that's HTTP only. So then there's disclosure tokens and logs. This is not as common, but if it does happen, it's much more devastating because the user does not even have to be in a position to sniff your traffic. They just have to find the log file, and those are often pretty easy to find. And one thing is fun, this is, by the way, probably illegal, is this Google dork. All Google dorks are pretty much illegal, but I don't think they'll lock me up because I'm finding vulnerabilities on somebody's server. But these Google dorks are always good, clean fun. So why would someone put JSession ID in the URL? Well, the first page is people who are actually writing pages about JSession ID. So that's all right, but you only have to go to the second page to find some clown that has just put it in the URL. Yeah, the British Library. Okay, so these guys have the session ID just right up there. And therefore, this means it's going to be in the logs and the history and the favorites and everywhere, all over the place. You know, this information just shouldn't be that public. So now if people do this, if they put the session ID in a foolish place like that, then a whole bunch of fun attacks occur. It will be in the browser logs on the history on this browser, on the web server. It will be at all the proxy servers. It'll be in all the reverse proxies. And what's even more fun is it'll be in the referrer header if I get them to go to another page. So here's an awesome one. You send her a page, go to another page, and the referrer has the previous URL, including the session number. So all you do is if you had a webmail application with this vulnerability, you just send emails to people with a link to click that goes to your server. And in the header comes their session cookies. It's just bloody awesome. You don't even need cross-site scripting or anything. You just need someone to go from the authenticated webmail page to your page. And this is why people often say, don't click on links in email, type in the URL. It would be better, although I don't even think that would save you in this case. Anyway, so, all right, so that's one fun one. Another thing is, this is, by the way, one of the pointless things in your book. They say this over, there's two things they say, which all security books will always say, which is complete bullshit. Which is, don't let people log in multiple times at the same time and cause sessions to expire. Nobody ever does this except your bank, because everybody wants to be logged in on their iPad and their phone and log in here, and they're not willing to log in at the desktop and then find out that they're logged out on their iPad. Now they have to try to type in their password again. So everybody lets you have multiple open sessions from different machines at the same time. And of course, it's not safe, because now the attacker can log in and you won't know anything's wrong, but everybody does it because it's a user feature. Anyway, there's another fun one. He said, I haven't seen this, but this would be awesome. They have a static token, like your token is 42. When you log out, next time you log in, your token is 42 again. Remember, your token will always give you the same token. So basically, your token is a permanent session. And I have seen something like that, which we'll get to. Here's another one. This thing base64 decodes to user equals def and then a random number, but you might be able to use this same random number for a different user if the logic is not good enough on the server. It just has to be valid, and since it's a valid number, I can get in there. Then there's session termination, and this is a huge one. I've been studying this one for years. When you are done with a session, what do you do? Most logout buttons don't do anything. All they do is delete the cookies in your browser. That's it. So I went through, I heard about this in Office 365, that Office 365, you could take a cookie, log out, and then send the cookie and you're logged in again. You don't need to really log in. And I found that I could just save the cookie and change my password, and the old cookie kept working forever. And I went and tried sites on the web, and I found about half the sites that I could find were vulnerable to this. I found dozens of them, and other people did. The first two I found were my bank. American Express was vulnerable. So this one's kind of fun. And this is the kind of research I did back before I found out it's illegal. But it is actually pretty awesome. Cookie reuse. Yeah.
Your American Express password?
I am. So hacking into my own account might possibly be legal, but not according to CFA. The CFA says if I send a request to their server and I gain information I'm not authorized to have, I broke the law. And I'm not their security administrator, so I'm not authorized to know about their problems. So, but I recorded a video. I was at DEF CON, in fact. I recorded a video of hacking in my American Express account without the password and my Chase account. And I sent this to both of them, and they both promised to call me back, and they never even called me back at all. And I really am a customer at both places. But in both places, all you have to do is log in, copy the cookie, log out, change your password, and the old cookie still works forever. Now, at these banks, they actually do have a session timeout after like 10 minutes of inactivity. So if you were to steal a cookie, you couldn't just keep using it too long. But other places don't. And there's just a ton of them. So here's the ones: American Express, Chase, Amazon, IBM, Netflix, Flickr, SoundCloud, Twitter, WordPress, Yahoo, YouTube, most newspaper agencies. These all have the same problem. You can reuse a cookie forever. So if someone steals your phone, or they intercept your traffic and they get your cookie, you are just screwed. Even if you change your password, they're still in. The only thing you can do is cancel your account and start over again with another email address, which is bloody awesome. And what this means is they have a logout button, but that logout button does not do anything. It does not invalidate the token on the server. There's nothing you can do that will invalidate that token that I could find at most of these sites. And like many other things, I was not successful at making anybody care. There's a whole bunch of these vulnerabilities we've known about for years, and every year or so somebody makes a theatrical demonstration of how awful it is, and you think someone will care. It's sort of like at some point people will notice that Donald Trump is a lunatic. And every week the news, Donald Trump finally did something so rotten, everyone's going to desert him, and everyone says, oh no, that's fine. And it goes on like this. At some point, something will be so awful it will make a difference. But this wasn't it. Anyway, so if you steal a cookie, here's a cute one: session fixation. I can sometimes alter the traffic and feed you a session, then you'll log in and the server will accept that session. So I can determine your session number. Yeah.
I'm just wondering if they don't really care because it's only going to harm small amounts of users at any time, right? Nobody can just gain access to 50,000 users doing this, right?
That's true. The ones that require you to be in the middle is less of a risk. The ones where you don't have to be in the middle are much worse. That's why Facebook, I think, paid $10,000 for the guy that found out that you could go to some page and get a number, and that was the same number that was used in a password reset link. So he could really get in anybody's account anytime. That they care about. Yeah. And that's the point. All these vulnerabilities have levels of harm, and that you take some business experience to understand what level of harm they really are. And one of the most common flaws of beginning security researchers is they find something that really doesn't matter, and they scream bloody murder, and they're mad and everyone ignores them. They say, dude, it doesn't really matter. You can't really buy large amounts of product and have it shipped to someone with that, so we really don't care very much. Anyway, so there's cross-site request forgery, where you trick the user into submitting a request containing a cookie that goes to the attacker's server. Another issue is cookie scope. When you set a cookie, by default, it will go to the domain where you set it and all subdomains. So if I set a cookie by games.sam/.info, it will be sent to foo.games.sam/.info, but not to sam/.info. It goes to the domain that set it and all domains below that. You can specify it. So here you can specify domain wa.app.com, and it will now go to every subdomain of that, like bar.wa.app.com. You can't set a cookie for some other domain, like yahoo.com when you're not Yahoo, and you can't set it for a top-level domain like .com or anything. That would be horrible. But here's a prominent example. So you have blogs.com. They set a cookie for each user, and each user can create blogs, but joe.blogs.com and sally.blogs.com are both subdomains. So if you get a user to come to your blog, you'll get the cookie of their authentication. So this is a serious problem. And you cannot fix it with any cookie manipulation feature. What you have to do is arrange your domains better. Put the authentication page at www.blogs.com so that the user's individual blogs are not a subdomain of it. That's the way you prevent this, so the cookie isn't being sent to individual users. And if you set a cookie here, right, that would be, if you set a path, this path looks pretty good. You can make it this cookie only works with path apps. It would only be apps and things below that, but there's actually a trick in JavaScript to create a handle which will totally fool this. And this blog is kind of interesting. It kind of reminds me of a Microsoft vulnerability in FAT, where if you, in Microsoft servers, bypass traverse checking is on by default in local security policy, and that means if I have C:/secure, and in there I put public, a subdomain of, you can do that. You can't do that on Unix. You have to be allowed into every folder above it. But on Windows you can. You can make a public folder inside a secure folder, and you can go and then go up and get up into the secure folder from the public folder. And there's a trick here where you define a path that makes it look like you're in the public part when you aren't. So it turns out path is actually completely useless in the presence of JavaScript. So anyway, this is just the other side of this is why they always write this chapter. They go through a bunch of attacks, and then they have recommendations how to be secure. Don't do these stupid things. So make strong tokens. You have to protect them so nobody steals them. Your strong token should just have a large set of values. It should be really random so nobody can predict it. It should not be built of predictable components or have some kind of structure. It should not be built from the username and the date and all that crap. It should just be a random number. And you should store everything about the session on the server, the username, the shopping cart, everything. When you go up there, so all you get is a random number, and it tells you which record in some database to look in, and that has all the information. None of it is being passed up from the user where it could be manipulated. And be aware that a lot of random numbers are not really random. Like Java's famous for this. The Java's random number is not random enough. The C random number is not random enough. You have to be careful. And here's other sources of entropy you might have. This is one that he recommends. You could take the source IP, the port number, the user agent, the time of the request, and combine all that stuff and then hash it. And now you've got something to seed your random number generator with that is really hard to predict. Another thing that's good is to add a secret. Known-only server, like 10 bytes of stuff before you hash it. So people, even if they figure out the structure, they can't predict that. These are good tricks transmitted over HTTPS with the secure and the HTTP only flag. And don't put the token in the URL. And what the logout button should do is invalidate the token on the server, so that if some more request comes in with the old token, it won't be accepted anymore. I was amazed when I discovered that more often than not, that is not what it does. What the hell else is a logout button supposed to do? I thought it would mean whoever stole my cookie can't get in anymore, and it doesn't mean that at all.
Why don't they just do
Yeah.
that?
That's a very good question. And I did the usual thing of yelling and posting blogs and showing it at DEF CON, and I did not get any developers coming to me to explain why. I think the general answer in this business is most developers don't even understand the question. And that's usually, I think I just used like my platform and did whatever the book told me to do on my platform, and I don't really know anything about where the tokens come from or anything. But it would be nice if people would explain to me how this happened, but I would just assume it is the path of least resistance to get the job done in whatever platform they're using. And they don't really care about the details. They assume the designer of the platform worked out the details, and that's often not true. Anyway, so your session should expire. He says that. I don't know what planet he's on. He thinks anybody's going to do that. That would be nice, sure, fine, but nobody's going to do that any more than they're going to use 20-character random passwords. It's easy to tell people stupid things like that, which they will ignore, but doesn't really accomplish much. Don't allow concurrent logins. There's another joke. And if you're going to have administrative functions with tokens, you have to protect them. You can use the domain and path to limit your session cookies. You should remove cross-site scripting vulnerabilities. There's another one that's never going to happen. 80% of websites are vulnerable. There's no automated scanner that will find them, so this is another, yeah, sure, tell me another. This is like only hire trustworthy people that won't betray you. Thanks a lot. If I knew how to do that, my problems would be solved. But anyway, so anyway, one thing that does make sense is to notice these suspicious requests, like deformed tokens, invalid tokens, should be interpreted as attacks and blocked by your IDS. That makes sense. Two-factor authentication is another good thing. That helps. Using hidden fields instead of session cookies might help because they aren't sent in every request, but then you have to be coding them every place to get them sent, and I don't think that's going to be fun. But you should create a fresh session after each authentication so that they are not reusing old session tokens, because that's just asking for trouble. And you could even have a per page token, where every page has a different token, and it verifies it. So this means they have to follow your path. First this page, then the login page, then the list page, then that page. And that would prevent a lot of these attacks that involve sending repeated requests to the same page with different tokens or something. It's a possibility. I think in practice this would be way too much bother to maintain as you keep modifying your site and adding more pages and more possible paths. But this one makes sense. Part of your IDS should be looking for these kind of attacks and noticing when some clown is flipping the bits in a token one by one. You should be able to detect that if you make any attempt to. And if you find any of these weird things going on, terminate the session. Cancel the cookie on the server because some clown is obviously trying to break into it. So we should interpret that as a attack, and that makes sense. All right. So we're down to this stuff. Okay, what's the encryption method that can be exploited by flipping single bits in the ciphertext? I'm not sure your algorithm there is going to lead to success, but it's possible. He's trying to fuzz the eye clickers here. Anyway, so I'll quit it. I'll quit at 30. Well, that's another one, yes. All right, and that's cipher block chaining as that vulnerability. Not ECB, but cipher block chaining, where you flip one bit and it ends up flipping just a few characters, and you can sometimes get lucky and hit something good. All right. Which token leaks in the referrer header? Which is mighty rude. All right. Guess I'll quit at 25. All right, and that is the query string. In the URL, if you put something there, it's in the referrer header among many other foolish places. All right, which type of token is not visible to JavaScript? All right, guess I'll quit at 25. All right, that's the HTTP only cookie. Good, a popular answer. All right, and last one, what should your logout button do? Obviously, half the developers on the web need to learn the answer to this question.
I'm trying to vote right now.
Yeah? Oh, it's really? It says it's listening? All right, let's try stopping it and restarting it. Let's see. How about now? Try. I'm seeing Donna coming in. Okay, like everything on computers, it just needed to be shut down or turned on again. So I'll quit at 20. Like I said, he wants to hack this app, and I bet it would be pretty easy. It's a pretty poorly written app. I'm sure it's made a bunch of these mistakes. All right, so the logout button should invalidate the token on the server. It's amazing to me that someone has to tell them that. I never would have occurred to me to do anything else, but they did. All right, so this is 129S, Chapter 7B.